Hey everyone, welcome to talk show number 14. So, I went to a Korean restaurant for dinner today called Yummy Tofu, and the owners must have so much courage to call their place yummy, but it actually is pretty good. So we had to wait outside for like 20 minutes or so. It was me and my dad. My mom was coming from a holiday party, so um, my dad asked me this question. He was like, why is it that whenever you see a rainbow, it's always the red on top and like violet on bottom? Like, why is it always that order? And obviously, I didn't know the answer. But the only thing I knew before I did my whole investigation spiel was that red corresponds to lower frequency of the spectrum, and violet corresponds to higher frequency of the spectrum. That's why it's called infrared and ultraviolet. But anyway, here's what I did tonight.
Hey, look, I set up a rainbow. This actually legitly took me like 20 minutes or so. It was so tricky with this water bottle, but I'm so glad I was able to do it. And you can see this rainbow from any vantage point, really. It's mostly the same. Let me just scoot far away. Yeah, I guess it fades a little. Have to be in this like optimal position to see it. Let me focus now. Yeah, it looks great. Let's see what it looks like if I just put my camera in front of the rainbow. Hmm. Wonder if you see anything. Because I can't see the screen.
Okay, so now we get to the funnest part of the rainbow experiment, which is to actually explain why the rainbow is created. But first of all, this banner is so annoying. I just can't. Anyway, let's go to the freeze frame. And I've labeled most things nicely for you. So here's the light source, and once it seems to be most concentrated here when it hits the plastic in the water. Now, the plastic water refracts this light so that it is mostly concentrated here now. And what refraction means is that when light passes through a medium, the medium can redirect the light. So air doesn't refract light a lot because air is very sparse, but for denser objects like plastic or water, yes, they can influence which direction the light goes. Now, how is this rainbow formed? According to Wikipedia, this rainbow is formed at 42 degrees opposite the source of light. So let's break this down here. Uh, there are two sources of light potentially. This one and actually this one, because the white sofa will reflect this very concentrated light back to where it came from, which is presumably here. So opposite this light source is where this plastic really is, and 42 degrees from this direction is actually here. So we can argue that the light source is actually this thing that causes this rainbow. Isn't that crazy? Of course, I could be wrong, but that is how we would get the 42 degrees. So wow. Anyway, now let's try to answer the original question, which is why the red appears on top and the violet appears on the bottom. Well, according to Wikipedia, but this will be so cool because we have a real life example. The higher your wavelength, the more you refract. And what that means is, in this case, is you see this light source, right? The more you refract, the sharper your angle. So then the angle between the blue up to this point, back to the light source, is smaller than the angle that red takes to go up to this opposite source and back to this light source. So then but then it looks inverted because the red, having a larger angle, is therefore farther from the light source than the blue. So that is a basic explanation of how this rainbow came about. I don't really have the mental bandwidth to explain how real rainbows form. It's already almost 1 a.m. But yeah, hopefully you found this really interesting. I found this so interesting, although it did take a while for me to process this information. Awesome. And that wraps up all the fun videos for this week. I tried to mix things up because I thought you guys would be kind of bored of looking at my face the whole time. So I took some more footage, and editing stuff in iMovie is super fun, super nostalgic. So I hope you had just as much of a great time looking at all this new media as I did. And so yeah, with that, happy Friday, happy weekend. I'll see you on Monday.
Wow, what a pattern this is. Woo, woo.